Students, good morning. Today I am going to teach you Banker's algorithm. Deadlock avoidance, deadlock detection, and deadlock recovery are deadlock algorithms. And today we are going to see deadlock avoidance Banker's algorithm. And the path pushing, diffusion detection, and edge chasing are deadlock detection algorithms. And if you take recovery, rollback recovery, preemption, killing processes are deadlock recovery algorithm. And if you take deadlock prevention, any one of these four conditions: mutual exclusion, hold and wait, no preemption, circle wait. By eliminating any one of the above four conditions, we can prevent the deadlock. Let us see the bank example. Assume a bank has only 50,000 in its account. Three people are going to bank, and first person A wants to take 10,000, and the second person B wants to take 20,000. That is, he wants to withdraw 20,000. And third person C also wants to take 50,000, but the balance in the bank is only rupees 20,000. So the bank could not pay person C. So the third person C is waiting in the bank to withdraw money, and at the same time, the bank is also waiting for a person who can deposit at least 30,000 so that it can pay person C. Here, the third person waits for the bank, and the bank is also waiting for a person to get money. This situation is called unsafe situation, and this unsafe situation will lead to deadlock. So what is the solution? We can change the order of persons. Assume person D comes to the bank and deposit 1 lakh rupees. Okay. So the bank is able to give 50,000 rupees to the third person C. The order of the person is A, then B, then C, then at last D. So it is an unsafe order. Okay. But if the order is as below, first D, person D, then A, then person B, then person C, then there will be no waiting problem. Okay. If the person D, first the person D goes to the bank and deposit 1 lakh, then the bank will be able to give money to the persons A, B, and C, right? So there will be no waiting problem. See the order. See the next order: A, B, D, C. It is also safe order or safe sequence. Or the person A, D, B, C is also a safe order or safe sequence. Now let us go to the Banker's algorithm. Banker's algorithm is a deadlock avoidance algorithm which allocates resources in a way that deadlock can be prevented. Okay. Now let us see what are the arrays used in Banker's algorithm. There are 5 types of arrays used in Banker's algorithm. First one is max. Max means maximum number of resources requested by each process. The next one is allotted. That is how many resources allotted to each process. The next one is available. Available means at last how many resources are still available in the system. That is how many resources are not allotted. Okay. The need is a two-dimensional matrix that is an m into n matrix sequence representing the number of remaining sources for each process. Then the last array is finish. It includes a Boolean value, that is true or false, indicating whether the process has been allotted to the request resources or not. And this Banker's algorithm comprises of 2 sub-algorithms: the safety algorithm and the request resource algorithm. And it is a safety algorithm. It consists of 4 steps. Just go through all the 4 steps. Just see the algorithm. I will explain now. Before going to Banker's algorithm, I will give you one magician example so that it will be easy to you to understand the Banker's algorithm. Okay. Assume there are 5 magicians, magician A, B, C, D, and E. Okay. Look at the second column, the number of balls given to each magician. The third column is the maximum number of balls a magician can play with them at a time. And last column is the balls available after allocation. See, second column, one ball is given to him, and next column is maximum number of balls he can play at a time. See, take magician A, the number of balls given to him is 1, and the maximum number of balls he can play at a time is 1. Okay. Take magician B, the number of balls given to him is 1, and the maximum number of balls he can play at a time is 6. Take magician C, the balls given to him is 3, and the maximum number of balls he can play at a time is 4. Similarly, magician D and E. And at last, the balls remaining at hand is 3. That is, 3 balls are not given to any magician. That is not allotted to any magician. Okay. Generally, to play or to execute a task, general formula, the need should be less than available, or at least the need should be equal to available. Okay, always the need should be less than available. Then only we can play, then only we can execute, then only we can give some money to somebody. Okay, always need should be less than the available. That is a general formula. Now comes to the magician example. The balls available in hand is 3. At last, the show organizer has 3 balls. The 3 balls are not allotted to any magician, not given to any magician. Now, how to calculate the need? What's the formula to calculate need? Need equal to maximum minus allotted. Okay. Let us take the balls allotted to each magician, a maximum number of balls they can play at a time, and what's the need. Okay. Take the first magician A, the number of balls allotted is 1, maximum number of balls he can play is 1. So need is nothing but need is maximum minus allotted, right? So 1 minus 1, 0. His need is 0. Now compare the need less than 3. 3 is number of balls unallotted, right? So 0 less than 3, true. So he can play. His need is less than available, so he can allowed to play. Then after playing, what is the condition? After playing, he should give back the balls allotted to him to the show organizer. So how many balls allotted to magician? 1 ball, right? So he has to give back the ball to the show organizer. Okay, how many balls remaining in the remaining 3? So first magician A give back 1 ball to the show organizer. Organizer already have 3 balls. So 1 plus 3 equal to 4. So the number of balls available is 4. Take the second magician B. The balls allotted to him is 1, but the maximum number of balls he can play at a time is 6. So 6 minus 1, 5. Okay, now the need is 5, and see the formula. 5 is not less than 4. The balls remaining is 4, but 5 is not less than 4. False. 5 is greater than 4, right? So it is false. So he cannot play. His need is greater than available, so he cannot play. Then take the third magician. The balls allotted to him is 3. Maximum number of balls he can play at a time is 4. So need is 4 minus 3 equal to 1. 1 less than 4. True. He can play. Then after playing, he has to give back the balls allotted to him. So 3 plus 4 equal to 7. Okay. He has returned back 3 balls. The balls already available is 4. So 3 plus 4 equal to 7. Then go to the next magician. Balls allotted to him is 2. Max number of balls is 3. So 3 minus 2, 1. 1 less than 7. True. He can play. So he can play. Okay. Then he has to give back the balls allotted to him. So how many balls allotted to him? 2. So he has to return 2 balls to the show organizer. 2. So 2 plus how many balls are available in hand? 7. So 2 plus 7, 9. Go to the last magician. Number of balls allotted to him is 2. Maximum number of balls 3. What's the need? 3 minus 2, 1. So 1 less than available balls 9. True. So he can play. Then after playing, he has to give back the balls allotted to him. So 2. The balls remaining in hand is 9. 2 plus 9, 11. So the maximum number of balls available is 11. And if you take the magician, second magician, B is not played. Others are played. Magician A played, and C, D are played. Only magician B not played. So only second magician not played. Now balls available in hand is 11. Now calculate the need. 6 minus 1 equal to 5. 5 less than 11. True. So give 5 more balls and let him to play now. Okay. Now all magician has played with the balls. The same concept is followed in the deadlock algorithm also. Now let us go to the Banker's algorithm. Assume there are 5 processes and 4 resources. Maximum number of resources A. There are 4 resources A, B, C, D. And if you take the resource A, number of resources 3. Out of 3, 2 has been allotted and 1 not allotted. And if you take the resource B, number of resources available is 14. Out of 14, 9 has been allotted and 5 not allotted. Not allotted means 5 available. Similarly, resource C and D. So the resources, what are the resources? The resources are hardware, software, that is CPU, memory, files, filter, etc., etc. N means number of resources and N means number of processes. Now the explanation of safety algorithm. Assume there are 5 processes P1, P2, P3, P4, P5 and 4 resources A, B, C, D. Look at the second column. Second column is the allocation of resources. Third column is the maximum number of resources requested by each process. And the last one is the available resource. That is not allotted resource. Okay. And if you take the process P1, take the resource A. 0 resource of A is allotted. B, 0. C, if you take the resource C, 1 is allotted to the process 1. And if you take the resource D, 2 instance of resources D has been allotted to process P1. Okay. And maximum number of resources requested by process P1 also same 0, 0, 1, 2. So the need will be 0. And if you take the process P2, the resources allotted to process P2 is 1, 0, 0, 0. And the maximum number of resources requested by the process P2 is 1750. Okay. And take the process P3. The resources allotted to P3 is 1354. And the maximum number of resources requested by process P3 is 2356. Similarly, if you take P4, 0632 and maximum number of requested process is 0652 and take process P5, 0014. Maximum number of resources requested by process P5 is 0656. And at last, the number of resources not allotted to any process is 1520. These many processes are not allotted. Okay, 1520. Okay. Let's go to the problem. What's the problem? First, calculate the need matrix. Second, calculate whether the system is in safe order or not. Okay. So unsafe state means deadlock may occur. Safe state means deadlock will not occur. If a system is in unsafe state, then there is a lot of chance for the deadlock to be occurred. If a system is in safe state, then there will be no chance for the deadlock to occur. Now go to the algorithm. Step 1. What is step 1? Work and finish are 2 vectors of size m and n. Initialize work vector with available resources in the system. That is, how many resources available at last? How many resources are not allotted? 1520, right? So initialize the work vector with 1520. See the work vector, work array 1520. Then take the finish array, finish vector. Initialize finish vector, finish of I equal to false for all I 1 to n. Initialize all the elements of finish vector with false, that is 0. False means 0, true means 1, right? So work vector will be initialized with the currently available resources of the instance of the resources 1520 and finish vector is initialized to false. That is f equal to 0. Now write the dimensions of each array. Allotted, take the array allotted is a 2-dimensional array, 5 into 4 cross matrix. And if you take the maximum array, it is also a 5 into 4 cross matrix. And if you take the available array, it is a 1-dimensional array. And if you take need also a 2-dimensional array, any 2-dimensional array. Now, how to calculate the need? The formula, take the formula for need equal to maximum minus allocation. Now, take the process P1, P2, P3, P4, P5. Calculate the need. What's maximum resource requested by process P1? 0, 0, 1, 2. What are the resources? How many resources are allotted to P1? 0, 0, 1, 2. Just minus 0 minus 0, 0. 0 minus 0, 0. 1 minus 1, 0. 2 minus 2, 0. So need is 0. Take the process P2. Maximum is 1750. Allotted is 1000. Just minus. 1 minus 1, 0. 7 minus 0, 7. 5 minus 0, 5. 0 minus 0, 0. Similarly, P3, 2, 3, 5, 6 minus 1, 3, 5, 4. 2 minus 1, 1. 3 minus 3, 0. 5 minus 5, 0. 6 minus 4, 2. Similarly, P4 and P5. So we have calculated the need matrix. Okay. Do you understand how I calculate the need? Do you understand? Now calculate the safe sequence. Now take the first row from all need, allotted, and available matrices. Take the first row in all need, allotted, and available arrays. Okay. Then go to step 2. Step 2, find an I such that both finish I equal to false. Need of I less than equal to work. If no such I exists, then go to step 4 or go to step 3. Okay. Now, take the resource allocation table and take the need matrix. Take the process P1. What's the process of need of P1? 0, 0, 0, 0. Look at the top right corner. What's the need of P1? 0, 0, 0, right? Now, come to step 2. Finish I equal to F. Finish I equal to false. Need I less than equal to work. Work means available. So, what is the need of P1? 0, 0, 0, 0. Less than equal to what's work? What's the work vector now? 1520. Compare 0, 0, 0 less than 1520. True. Need is less than available. So the process P1 can be executed because its need is less than the work, less than the available. And after playing, after execution, it should release the resources allotted to it. Okay, then go to step 3. What is step 3? Work equal to work plus allocation. What's the work now? 1520. What's allocation? Allocation means resources allotted to the process P1. How many resources allotted to process P1? 0012, right? So add that 0012 with the work 1520. What's the result? 1532. Okay. So the resource released by P1 is added with the available resources. So the work vector becomes 1532. That is, the work vector is updated now. Now the work vector is updated. Can you understand what I'm saying? Now see the updated work and finish array. Now the work vector is updated 1532 and finish vector is also updated. That is, f of 1 becomes true. All other elements are false. F of 1 becomes true. Now see the table, the available resource is 1532. Okay. You understand? Then iteration 2. Now take the second row from all need, allotted, and available matrix. Okay. Take the second row from all the tables. Now process P2. What's the need of process P2? Look at the top right corners, 0750, right? So now go to step 2. Finish I equal to F. Need of I is then equal to work. What's the need of process P2? 0750. What's the work now? 1532. So 0750 is not less than 1532. Not true. False. So go to step 4 as per the algorithm. What is step 4? If finish of I equal to true for all I, then step is in step state. But here, not all Fi's are true. Only F1 is true, all others are false. So again go to step 2. Okay. Iteration 3. Now take the third row from all the arrays. Now the process P3. What's the need of process P3? 1002. How many resources are allotted to P3? 1354. Now go to the formula. Step 2. Need of I less than equal to work. What's the need of process P3? 1002. Look at the top right corner. 1002. Less than equal to 1532. What's the latest work available? What's the resource? What's the latest resources available? 1532. So 1002 is less than 1532 true. So process P3 can be executed and it will release the resource allotted to it after execution. So go to step 3. What is step 3? Work equal to work plus allocation. What is work now? What's the latest work now? The latest work 1532. How many resources allotted to process P3? 1354. Add work plus allocate. Now the work becomes 2886. That is the work vector is updated now and finish of t equal to true. As per the formula, the finish will becomes true. So the updated work and final arrays. Work array becomes 2886 and work and finish is true, false, false. Okay, this is updated work and final arrays. Now the sequence. Now the new sequence is P1, P3, not P2, because P2 is not executed. P1 is executed, P2 not executed, and P3 is executed. So the sequence becomes P1, P3, not P2. Then iteration 4. Now take the fourth row from all the arrays. Now process P4. What's the need of P4? 0020. How many resources allotted to P4? 0632. Now go to formula. Need less than equal to work. So 0020 less than 2886 true. So P4 can be executed. Now go to step 3. Work equal to work plus allocation. So 2886 plus 0632. So the work array is updated to 1411 Then finish of 4 equal to true. As per the formula, finish of 4 equal to true. So the work and finish array becomes, now see the work and finish array. Work array becomes 2, 14, 11, 8. And finish array becomes true, false, true, true, false. Okay. Now the sequence is P1, P3, P4. Iteration 5. Now take the fifth row from all the arrays. Process P5. What's the need of P5? 0642. How many resources allotted to P5? 0014. So apply the formula. 0642 less than 2, 14, 11, 8 true. So process P5 can be executed. Now go to step 3. Work equal to work plus allocation. So 2, 14, 11, 8 plus 0014. Now the work array becomes 2, 14, 12, 12. And the finish of 5 becomes true as per the formula. So the work and finish array becomes, see the work array becomes 2, 14, 12, 12 and the finish array becomes true, false, true, true, true. Now the new sequence is P1, P3, P4, P5. First loop over. First loop over. Now the process P1, P3, P4, P5 executed. P2 is not executed. So once again, go to second loop. Okay, loop 2. The loop 2, P1 already played, then the control will come to P2. Now the process take the need of P2. What's the need of P2? 0750. So 0750 less than, what's the latest work? 214, 12, 12, right? So 0750 is less than 214, 12, 12. true. Now P2 can be executed because its need is less than available. Then step 3, work equal to work plus allocation. Now the work array becomes 3, 14, 12, 12. And F2 also will becomes true. Okay. Do you understand what I'm saying? Then the final stage of work and finish array. So work array becomes 3, 14, 12, 12, and finish array becomes true, 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 true. All f of I are true. Now, if we take the finish array, all f of I values are true, and the work array is 3, 14, 12, 12. Okay. Now the iteration comes to end. Now the sequence is P1, P3, P4, P5, P2. P2 is executed at last. Now this is the save sequence. If the processes are executes in this order, then there will be no problem in allocating resources to them. This is a safe order. Okay. Thanks for watching this video. Please subscribe it. Thank you.